So now something to really get the adrenaline flowing. And actually, you might see this tornadoes up here. It looks like it's got a hyperlink to it. It's blue and has a line underneath it. That's my reminder to watch the videos, the associated videos, especially with the units in this, the chapters in Unit 4. We'll have miscellaneous videos posted under the lecture pages for each chapter. So tornadoes, yeah, they're associated with thunderstorm cells. Not all thunderstorm cells will produce them. I believe the statistics are like 2 in 100. I have it somewhere on here. So general characteristics are they're associated with thunderstorm cells. They start out as, and I have a slide here to kind of in so many words say, if you've heard of a funnel cloud actually, the difference between a funnel cloud and a tornado, as I understand it, is a funnel cloud is not making contact with the Earth's surface, but it is a rapidly rotating, rising, air is rising within the vortex of a tornado. They generally have a central low pressure, which means that if you're looking kind of as the bird will look down at it, that it will be going counterclockwise. Okay, so that's how the rapidly rotating air is moving. We have a tremendous pressure between the center, we'll call the eye of the tornado, the center of the vortex, and just outside of it, and the pressure difference is 100 millibars, which is crazy tremendous. The pressure gradient force swirling that air around is just crazy. Tornadoes vary a lot in size. They can be just the vortex, the part that kind of interacts with the Earth's surface, can be anywhere from a couple of feet to a half a mile. It's just amazing. And their duration can vary a lot, from just a few minutes up to several hours. I think that's unusual to have a tornado last that long. And actually the reason that, or because they are so short-lived, it makes it hard to study them. So we're going to see that we're going to use what we call the enhanced Fujita scale to categorize tornadoes, and we are going to categorize them on their wind speed kind of after the fact by kind of doing a little bit of forensics sort of after the tornadoes come through and estimating its wind speed. So I thought I would go ahead and bring in a few photographs from last year's tornado in Joplin. And it was, as I understand it, just one tornado. Now within a single tornado, we're going to see that we can actually have, let me go ahead, this is a photograph of that tornado. We can actually have smaller, multiple vortices, what we call, within the tornado. But this, tornadoes have different shapes, and I think this is maybe what you might generally call a wedge shape. Okay. So this is the aftermath. This is Joplin. And it's just amazing. One of the things I heard, you know, on a first, somebody who was actually there, just talk about, can you imagine the trees being stripped of all their life? This was May, so this would have been into spring. You can see this is like an aerial view, and I don't know if you can see the path of destruction that this tornado took through Joplin. And then back to your slides if you printed them out. This is a figure I got from the internet, and you can see that I'm not sure what shape we would call this. See how this wouldn't be a wedge shape. And the irony here is there is a rainbow in front of that tornado. Rainbow being created by the sun is behind us, low on the horizon, and we have kind of precipitation to go ahead and refract and reflect that light. So another tornado, another tornado. Now, one of the things is the only reason we can see a tornado, you know, it's just moving air, you know, circling around and being sucked up in the center. The reason we can see a tornado is it needs to be going ahead and interacting with debris. So actually you can kind of see the debris flying around here. And the other reason we can see a tornado sometimes is that basically we have condensation. So water vapor is going ahead and condensing to form a liquid, and that's kind of what happens in clouds, and that's what's happening so that we can see that circulation of air. So here's a table from your textbook. I think it's kind of interesting, looking at some kind of extremes with regard to tornadoes. So for instance, we're going to see that worldwide, the United States definitely is the hot spot for tornadoes. It's not the hot spot necessarily for thunderstorm cells, but we definitely have more than anybody else with regard to tornadoes. So the deadliest tornado was actually 1989, and it wasn't in the United States, it was in Bangladesh. And you can see the number of people that were killed in that tornado. 13,000 were killed and 12,000 were injured. So with regard to the United States, the deadliest single tornado, and we're going to see that there's something called tornado outbreaks, and that is where you have basically kind of, well, we talked about multi-cell systems, you know, the squall line and the mesoscale convective complex. So you could have multiple tornadoes form within those multi-cell storm systems. So a single tornado took 695 lives. Now this was back in 1925, and where did it hit? Well, it lasted a long time because it went between Missouri, Illinois, and Indiana. With regard to outbreaks, the number is just a little bit higher. We had a tornado outbreak, multiple tornadoes that same year, that same day, and it took 747 lives. Now, since 1925, the year 1925, we have improved our warning system. The biggest, the outbreak that had the most tornadoes was the outbreak that had 147 tornadoes. Goodness gracious. And it happened over a 2-day period in 1974. In 2003, for 1 month, we had 543 tornadoes in the United States. That's a lot of tornadoes. These next ones talk about what was the widest tornado, 2.5 miles. That's pretty darn wide. It made contact with the Earth's surface. The fastest, the highest speeds, 302 miles per hour, greatest elevation. This last one I think is kind of interesting. In what case did the tornado transport something the farthest? And the record is a personal check. And if you think about it, you know, when a tornado relocates stuff, you know, how do you match up that stuff with its owner? And a personal check is pretty easy to match up. So it carried this personal check 223 miles. Isn't that cool?